everyone, we're going to sketch and find the area bounded by the graph of the given equations. We have y equals square root of negative x plus 1 and y equals 2, and it's also going to be bounded by our x-axis and our y-axis. So basically, let's look and see what we have. Let's look at just this one right here. Y equals 2 is right here. So that one's easy. Let's look at this one. If we have y equals square root of negative x plus 1, if you square both sides, you get y squared equals negative x plus 1. So we can solve for x, and you get x equals 1 minus y squared. Also, note for this one, for our sketch, I can also write this as y equals the square root of negative x minus 1. So basically, this is a square root function that's shifted to the right by 1, and the y-intercept is 1 because you have a double negative there, and then since it's negative here, it opens to the left, so it would be like something like this. And again, this is just a sketch. This would go through down here. You did the plus and minus part of it. We don't have the plus and minus, so I'll just take that out. And now let's look at our problem. We're trying to find the area bound by these two equations and our x and y axis. So it's from here to here. So the area we're looking for, let's write this here. And again, this is a sketch. We're looking for this area, and that would be from 0 to 1 here. But what we're going to be doing is looking at the y-axis. So we're going from 0 to 1, and then we also have this area right here. So for us, that's your y. So to set up the integral, what we're going to do is write it as our area, which I'll call S, equals the integral, and we're going to look at the y. So I'm just going to write 0 to 1 x, but we're going to look at our y. So I'll show you that in a minute. And this is on the right side of y. This is on the left side of y. So from 1 to 2, you have to subtract, and then that would be x dy. Or let's substitute back in our x. So that's going to be the integral from 0 to 1 of 1 minus y squared dy minus the integral from 1 to 2 of 1 minus y squared dy. And then we can integrate that and find the area. So I'll write this down again. We had the integral. I'll do this really fast. So we have 1 minus y squared dy, then minus, for that left side, 1 to 2, from 1 minus y squared dy. All right, so when you integrate this piece, you're going to get y minus 1/3 y cubed, and we're evaluating from 0 to 1. Minus, this is the same thing, and we're evaluating this from 1 to 2. All right, so let's go ahead and substitute in our upper, so we start with the upper one. So it's going to be 1 minus 1/3. And then with the 0, you're just going to get minus 0. So that's the first piece. And then for this piece, we have minus. And when you substitute in 2, you're going to get 2 minus 2 cubed is 8, so that's 8/3. Then minus 1 minus 1/3. All right. Now for this one, to just keep our signs straight, what I want to do is just distribute everything and make sure I have everything. 1 minus 1/3. This is going to be minus 2 plus 8/3. And this one's going to be a double negative. So we have minus a negative 1. That's going to be plus 1. And then this is going to be, this is positive 1/3. So then you negate it, you get negative 1/3. All right. Now let's simplify this. We have 1 minus 2 plus 1. Well, that's just 0. So now looking at this, we have negative 2/3 plus 8/3. That gives us 6/3, which equals 2. And that's it. Thank you. Have a nice day. Bye-bye.